Today in class we talked about some review concepts, so I want to go back over those just in case you have any questions. The first thing we talked about was the parts of an equation. So let's say we have an equation y equals mx plus b. This is our slope-intercept form of a linear equation. We call it slope-intercept because m is the slope, b is the y-intercept. The slope tells us how our line moves. It tells us how steep it is, how flat it is. It tells us whether it's going upside down. The y-intercept is where it crosses the y-axis. So our line, boom, right there is where it crosses the y-axis. So our slope-intercept form is going to tell us a lot. It's going to help us graph a line anytime we want to. Now, we also have other things. This particular part of our equation has lots of names. Another one that we might see, let's look at another equation, y equals 3x plus 7. We might also call this the coefficient, and we might call this the constant. This is constant because this little part of this chunk or this term, this part here is going to vary. So if x is 0, this whole part becomes 0. If x is 1, this becomes 3. If x is 25, this becomes 75. But this part right here always stays constant. It never changes. Okay? We also have our variables. We call this our independent. And we call this our dependent. The reason, among other reasons, the way I like to think about it is the y variable is just sitting here. It's waiting for you to tell it what it's worth. The x is there's a lot happening. The x is being multiplied by 3. They're adding 7 to it. Because of that, y is dependent on x. X is our input, y is our output. So that's just the way they're named. But let's pretend that instead of y equals 3x plus 7, I had h equals 3t plus 7. I would also still know that t was my independent variable because it's got everything's happening to it and the h is just sitting there waiting. Okay? Now, we also did a couple of examples of combining like terms, and we did an example of the distributive property. So let's do those over again too. Let's look at this particular equation. We have 3x minus 2 plus 5 plus 4x equals 2x plus 4 minus 7x. So as I told you today in class, the first thing I'm going to do is I'm going to put a line right here, and that's going to remind me that I cannot distribute across this equal sign. So this is kind of like once I hit here, boom, I got to stop. Once I hit here, I got to stop. I can't combine across the equal sign. Now I'll be able to solve across the equal sign, but that's different. So the first thing that I'm going to do is I'm going to put up walls between my terms. So I'm going to, everywhere I see a plus or a minus sign, I'm going to put a wall in front of it to help me identify where my terms are. Okay, so now that I've got my walls up, I can see very easily I have a 3x, a negative 2, a positive 5, a positive 4x. And over here, I've got a 2x, a positive 4, and a negative 7x. I'm going to start combining the things that are alike. We also talked about the fact that in order for two things to be considered alike, everything after the coefficient has to be the same. So they either both have to be they either have to be constant. So like 6, 7, negative 12, those are like terms because they're all constants. Or you could have 3x, 5x, negative 34x. Those are also like terms because they have the same thing after the coefficient. But 3x and 3x squared are not like terms because they aren't identical after the coefficient. So in order for them to be like terms, everything has to be the same after the coefficient, or they have to be constants. Okay, so now let's take a look back at this problem. I'm going to start by identifying things that are the same. So I see a 3x here, and I see a 4x. But I can't go over here because I hit the wall. I can't go past the equal sign. So I have a 3x and a 4x. That makes 7x. Okay, I'm done with those, so I'm going to cross them off so I don't get confused and think I have to do something with them still. Now I have a negative 2 and a positive 5. Negative 2 plus 5 makes positive 3. So I've combined everything. I've simplified the left side of this equation. Now over here, I have 2x and negative 7x, which makes negative 5x. I'm done with those. And I have positive 4. Now, we would later go on and actually finish this up, but for today, we're just concentrating on combining like terms and distributing. So let's try a problem where we distribute. Okay, we have 8 times 3 minus x equals negative 4 times 2x plus 4. Okay, once again, I'm going to put a line through the equal sign to tell me that once I hit the equal sign, I can't combine or distribute anymore. When I see this parentheses here, this means that I have to take everything, I have to take this number 8 and multiply everything inside the parentheses by it. So that means I'm going to take my 8 times 3 and my 8 times, what's happening here? This is a little bit confusing. So I'm going to put a 1 in front of that x so that I can identify what the coefficient is so that I don't get confused and accidentally not multiply by negative. Now I see I've got 8 times 3, which is 24, 8 times negative 1, which is negative 8x. Now, if you find yourself forgetting to multiply by the second one, here's what I would do. I would actually write down what you're doing. So 8 times 3 plus 8 times negative 1x equals, and then we can do the same here, negative 4 times 2x plus negative 4 times 4. So if you find yourself forgetting, this might help you kind of keep track of what you're doing. So 8 times 3 is 24. 8 times negative 1 is negative 8x. Negative 4 times 2 is negative 8x plus negative 16. And again, we would continue to solve this problem, but we don't need to do, we're not doing that because we're really focusing on distributing. Tomorrow we're going to actually do some more focusing on solving equations, but I will leave that for tomorrow.